In this video, you're going to learn about how Kubernetes memory allocation works. So like with CPU, we have the distinction between memory requests and memory limits. Like with CPU, the request is used for scheduling. Nodes in a Kubernetes cluster have a certain capacity for memory, and the requested memory for all of the containers that the scheduler puts on that node cannot exceed the total memory. Because it's a request and not a limit, pods can use more memory than what they request. There is a caveat though. If a node begins to run out of actual physical memory, so not the scheduler here, we're talking about in-use memory by the containers on that machine, then it's the pods that have exceeded their request that will get evicted. Evicted means that the container will be stopped, so it'll be gracefully stopped rather than killed, and then it will be moved to another node. If there is no other node that it could fit on, your pod will go back to pending, having been evicted. Memory limit, on the other hand, is used as the control group memory limit, like we saw with the experiments for Docker when we set -- memory and -- memory swap. That means that once you've set a memory limit on your containers, your processes, your Java applications will be killed if they exceed that. It's the memory limit which will affect Java ergonomics, because request is only used by the Kubernetes scheduler and the Kubernetes eviction process. So that begs the question, should you set requests, limits, or both? And the answer here is different than for CPU. For CPU, we recommend setting requests without limits. However, for memory, we always want to set a request and a limit. The reason that we want to set a limit is because if we don't, JVM ergonomics will be based on the host. So that means if you've got a Kubernetes cluster with a node with 128 gigabytes of RAM and you didn't set a memory limit, the JVM would pick up 128 gigabytes of RAM and then give itself a max heap of 32 gigabytes, which is probably not what you want. Especially when your JVM inside a container can be moved to a different node, say with a much smaller amount of memory, and suddenly your application would have a very different heap. Now, it normally makes sense to set the request equal to the limit for JVM applications. This is so that we don't get put on nodes. We then use more than our request, either because we've set it smaller than our limit or we haven't set it at all, and then we get evicted. And ideally, we don't want our pod to be evicted. So now that we understand about CPU and memory, requests and limits, here's what a typical deployment will look like. Or here's what the containers section of a typical deployment will look like. For requests, we'll set both the CPU and the memory, but for limits, we'll just set the memory. The reason, if you remember, that we don't set the CPU limits is because it can cause our container to be throttled even when there is excess cycles, CPU time available, and we don't want that to happen.